Thank you for joining, everyone. This is Jaime Sánchez from Felt. Let's just give it a couple of seconds while we get everyone here. All right, let's start. Welcome to Felt session for PostGIS Day 2025. Today we'll be talking about how we thought or how we use Claude to do geospatial queries in PostGIS. And with me, I have Mamata. So let's just first, Mamata, do you want to go and introduce yourself and then I'll go?
Yeah, hi. Thanks for having us. My name is Mamata Akella, and I'm head of cartography here at Felt.
And my name is Jaime Sanchez, and I'm the director of partnerships at Felt. Um, and me and Mamata go way back. We've been doing geospatial for a while, so it's really nice to be back together for this webinar. All right, let's get started. So for the first bullet point here, the first thing we'll do is do a felt overview, what the company is and how what problems do we solve. Then we'll talk about how what are the common pitfalls in for LLMs when it comes to spatial. Then we'll do the most exciting part, which is a demo of felt and our SQL AI and how we can query PostGIS and create really complex queries with a couple of just natural language lines. And then I'll explain what we've learned on how we should, best practices on how you should think about when you think about querying PostGIS with an LLM. Let's first start with the problem that Felt solves, which is building spatial apps and doing that fast. And in this image, you basically see the process uh, that takes most people when they do spatial apps to actually get a product out of the door. It starts on the left with the raw imagery, the raw vector data that you're starting with, all the way to the right with the production geospatial app. And what we see is that there's different personas or different roles working together. On the left, you have data scientists, GIS folks, data engineers that know geospatial, but maybe they lack the web development and the UX. On the middle, you have web developers and designers that have never done any geospatial SQL. Maybe they've done SQL, but they haven't interacted with geospatial SQL like PostGIS. And then you have business users that are just stuck waiting for weeks or months on getting their answers to their questions. And you can see the different processes of how this is an iterative process from creating a table to creating a query to a tile set down to a web server and just having an application. And again, this also requires a lot of collaboration between different teams, which can be hard. It can be something that is stuck in GitHub or stuck in presentations, and there's just needed to be a better alternative for that. And we've been promised a lot by Gen AI and AI, and I like this meme because it represents a lot of the pains that we've seen in the out there in some of our customers. Is yeah, my AI just wrote 10,000 lines of code in 2 minutes, feeling great, but now I'm gonna spend 2 days debugging it. So it's a lot of it is great, but a lot of it is also not as much. And so why is this? MIT calls this a Gen AI divide, and basically what we've learned from this report that they put out is only 5% of companies actually are seeing a return on their Gen AI projects. And one of the biggest gaps really is tools are not integrated very well. So ChatGPT or Claude or your LLM of choice is just really just not integrated well with your database. And this is what we're going to talk about today. Um, and to wrap it all up, we have the Felt platform. And this is why we've created Felt to enable collaboration, to build applications and dashboards fast and in seconds, um, to connect to pretty much any database and allow for collaboration. And so we're a platform that's cloud native, AI native, that integrates natively with the PostgreSQL ecosystem. And also, since we're here today at the PostGIS Day by Snowflake, also reminding folks that we integrate natively to Snowflake as well. Also, wanted to make a big note, a big mention of how we see the modern GIS stack, and for us, this is something that it couldn't be. We couldn't be here if it wasn't for the giants that PostGIS, Postgres are, as well as others like TPCanoe and QGIS and GDAL. So we ourselves use a lot of these, most of these, or all of these actually, in our own stack. And again, we couldn't be here without them. And a special mention to PostGIS because really it's a big enabler for us in how we do geospatial. So one of the things that Felt takes is a very like invisible AI approach to how we do our design in our product. So rather than being very buzzwordy about it, we like to introduce Claude and because we use Claude in just ways where our users really need it, not just throw it at you just for the sake of throwing it at you. And so there's three areas where we do this. First one is when you want to just extend the map and write some JavaScript. The second one is the one we're going to talk about today is SQL AI when you want to write a query against PostGIS. And the third one is just styling when you want to style a map and add a pop-up, for example. Um, and then something that we found as common pitfalls when we were starting to do the journey of SQL and AI was that in spatial, there's like three big areas where we saw a lot of the LLMs failing. The first one is just understanding the right geometry column to use. So boundaries versus centroids, or maybe the wrong table, like admin areas versus grid cells. So schema understanding is a big one. And the second one is just natural language can be very ambiguous when you think about spatial. Um, Near, overlap, inside, along, right? All these code some space into them, but maybe the LLM doesn't know what you mean when you say inside or overlap, and so it doesn't know which if it's STD within or ST intersect. So that can get messy. Or also, just an example of that is a Mississippi a state or is it a river? And then the other one, and this is again not an exhaustive list. This is just the top three that we found that we're sharing today. Is just when you're talking about a spatial problem, like for example, count the customers within a 10-minute drive of any store inside this metro area. This requires a multi-step logic. Like you can't just do that in one query, or if you can, it's just a really hard thing to one shot. So complex multi-step spatial logic is again a place where LLMs can fail. Uh, and with that, I will say one thing before we go to the demo and I share the screen to Mamata, is that our philosophy at Felt is one that we don't want to over-engineer the prompts we do to LLM because um, they change every month. So, right? Every 3 months, there's a new Anthropic model, a new OpenAI model. So baked into our philosophy is that these models will improve. So don't over-engineer the prompt because we're actually going to get a lot of benefits by waiting for some of these. So we'll go through the demo and then we'll explain how we think about teaching Claude and how we actually did it. So over to you, Mamata. I'm gonna stop sharing my screen and you can share yours.
Okay, thank you, Jaime. So yeah, we're gonna go through the process of using Felt AI and specifically SQL AI to query a bunch of layers to help us understand where we could potentially place EV charging stations in the city of Seattle. So for this analysis, we're going to use a few different layers that we have. One is demographics at the block group level to understand some commute patterns, a land use layer from the city of Seattle that is just land use classification because we want to locate commercial areas to place our charging stations. We're going to look at how areas that have a lot of traffic flow. So people that are commuting see these charging stations. And then we also don't want to place our charging stations near other EV infrastructure. So we're going to use this level 3 chargers layer. Okay, Jaime, and before I start with our queries, I'm just going to share the map with you so we can both be working on here together. So I'll just invite you as an editor.
Great.
And there you go. And we should see Jaime pop up on this map as well. Hi.
Beautiful.
Okay, so we're going to go to the felt library, and this is where you can do your source connections. Um, Here we're connected to this Seattle demo that we're looking at. And what you can see is I have all of the tables that we just looked at. So we have census block groups that are polygons. You can see here all of the attributes, including the geom and a bunch of demographic variables. We have the EV charging stations to understand our competitor location, the Seattle land use, again, with a lot of just zoning information. And then finally, we have the flow counts, the lines that we saw styled on the map based on commuter flow. Okay, so to get started, what many of us do, I'm sure, is when we're thinking about a problem, the first thing we want to do is kind of understand our data. So we can look at things like metadata to understand what all of the attributes mean, but sometimes attributes have cryptic names and it's kind of hard to understand what we have. So this is one way we can just start to explore what we want to do. So I'm just going to click here on the new SQL query, and this brings up our AI assistant. And here I have the prompt window, and here's where the code will be generated. So the first thing I'm going to ask is what attributes are in the demographics table to help understand commute patterns in Seattle. And click enter. And what you'll see is it's thinking, and then it'll give us an answer very similar to how you interact with other LLMs. Okay, so that's great. We have a little bit more information about the attributes, and now I want to do a little bit more of an advanced analysis between two tables. So I'm going to ask it to find all commercially zoned areas that don't have EV charging within 1 mile. So in the previous query, in the previous question, it didn't write a SQL query because we were just asking it about our data, but now it's going to actually start writing a query.
Yeah.
And I'm just going to fix this error here. Sorry, Jaime.
No, that's fine. And actually, just to comment on this is exactly what we mean when we're teaching Claude how to think spatially, because what we're doing is when we're fixing the errors, we're like putting in the error message plus sending what we call a schema tip. So it's not just saying, hey, fix this error. It's saying fix this error plus you have all these columns available to you. You have all these functions available to you. So it's actually by design. And it fixes it really quickly, as you saw from clicking twice there. And another thing that's quite interesting to note here is that not only it used STD within, but also it's doing ST transform because it knows Seattle's latitude is actually quite high and it prefers to use Web Mercator or EPSG 3857 as opposed to the projection that's currently stored in, which is WGS 84. And this is one of the things that's coming through when we were prepping Claude is, uh, if you use degree of longitude, this varies dramatically with latitude, as we all know. So, and at Seattle's latitude, which is around like 47 north, 1 degree of longitude is only about 69%, I think, of the distance of 1 degree at the equator. So this is why it's important to do these transformations and why we won't really have to think about them because Claude thinks about them for us.
Okay, and so here we're loading in our result, and what we should see are all of the commercially zoned areas that don't have EV charging within 1 mile. So I'll just
Nice. I see a couple of interesting things already, like this one in the north of downtown where I'm drawing a circle. Or also in the south, there's a space here clearly for EV. But we're not done yet. So what else can we do to enhance this algorithm or this analysis?
yeah. Okay, so I think what I want to have next is just regardless of our final analysis or our site selection, like we just still do want to know a little bit more about demographics in the area. And so we have this demographic table that we saw earlier, but all of the attributes in there are totals. And what we really want to know is what percent of the population commutes by block group. So we can make a choropleth map of that. And so I'll just ask it to do that. Uh, and so it's going through, looking at all of the columns we have and writing the case statements that we need to calculate the percentage. And so again, it understands like the function specifically, so it knows exactly what's wrong and how to fix it. Okay, and so now we have a new field, percent commuters, uh, and we can go ahead and symbolize that. So I'll
Yeah.
click
Yeah,
create
you can add
layer.
it, create the layer, and while it loads, we can do the next one, and I'll wait for it and I'll style it, just to show how collaborative Felt can be in this whole process.
Okay, so we've done a couple of things so far. We've found some commercially zoned areas that don't have EV charging infrastructure, and also created a demographic layer that we'll use in our final map. And now we want to do a more multi-step advanced analysis. But before we run the analysis itself, another great way to use Felt AI is to make a plan. So I'm going to ask it using the tables I have, how can I determine ideal locations for EV charging stations? And here, what it's going to do is kind of work through a plan with me and give me some ideas. Again, looking at the tables and coming up with some ideas. So this
Yeah,
is just like,
and
yeah.
this just sorry, Mamata, to add some context here. Like we found that asking, and I think this is a general approach that people have found, is asking it to create a plan like this works wonders when then you ask it to write the query because in the previous steps it was just like one-shotting a multi-step query and it wasn't getting it. Most of them don't get that. So planning is key and this two-step approach can improve success on this type of logic.
Yeah, that's a really great point. It's like we're building off a conversation now. Um, okay, so I'm going to go ahead and now ask it to write the query that's going to do this. I'm going to still give it some information. Uh, And you can be as detailed as you want, but I'm going to say, okay, so now write the query for the site selection analysis um, to identify the best commercial areas in Seattle to place EV charging stations. So just giving it the goal again here. And it did go through and see all of the layers, but I'm going to remind it. I want locations that are near areas with a high number of commuters, have high traffic volume, and won't have competition with existing infrastructure. Okay, and here it's again just going to tell us what it will do, and it'll start writing the
Nice.
query for us.
So I can see it's so many subqueries, which is great. So you have multiple tables there, and then it's gonna do a group by at the end.
Okay, and then it's going to tell us that
Yeah.
again.
Mm-hmm.
And then once this finishes, I'm just going to create a layer and we can look at it on the map.
Great. All right. So we have our layer there.
Yeah.
Nice.
Okay. So let's go ahead and style this. But before we do that, we can see if we had a live connection, we could actually set a refresh cadence. In this case, we don't need it to refresh. And also what's nice is you can see the SQL query back here. And if you want to make any updates, you can do it here and save it again to refresh it. Okay, Jaime, so let's see what we got. I'm gonna do this by categories
Mm-hmm.
and let's see what I think it said. It gave us something market opportunity. Um, and let me just symbolize this so we could see it a little bit better. And there we go. So we have now areas in the bright pink that are the most promising areas for shopping centers for EV charging. We have good opportunities with some competition around us in the orange, and then the purple are more high competition or moderate competition, it says, but I'd classify as high competition.
All right, that was a great demo. That was great that we were able to find, with a couple of queries in natural language, where to put EVs in Seattle. That's nice. And I personally really like just the way we're able to do that collaboratively, and in one map, be able to both do our own querying, do our own styling, and come together into one solution there. Um, then we often get asked how does all of this work? Well, at the core of it, there's a system prompt that we build into this so that we're able to get the most out of PostGIS. And so when we think about this, we go back to the pitfalls that we saw a lot when we were querying LLMs for spatial queries. And we'll share today not all of them, not all of the solutions, but the three that really improved our success of querying the most. And when we say success, how we measure success is not really on matching exactly the example query that we have, like the example truth query. It's just it's matching the data results because you can imagine if you've used PostGIS before, if you've done any SQL querying before that, you can arrive to the same conclusion in different ways. So really what we're how we compare it is with the results of the query. And the first thing is feeding in spatial knowledge. LLMs love tools or love functions, so the whole repertoire of PostGIS functions that you have available. This is something that they already know because they've been trained with SQL and just with a corpus that includes PostGIS. But we reiterate, our system with them. We also do clear guidance on geometry and geography. Um, we do a lot of like finding what is the right like geometry column to use based on the rest of the context of the table. We also note on the CRS expectations of like EPSG versus projected. Um, the other one that we do, and this is quite interesting and actually drove a lot of the success up, is to describe tables in geographical terms. So whenever you connect a table, or like, sorry, a Postgres schema, when we scan all the tables and the variables for each table or the columns for each table, what we do is we ask the LLM to also describe that table in geographical terms. So the roads table is not just a road table with its variable, it's a Beijing road network with a line string geom describing that road network. The counties table is not just county table, is a Arizona administrative boundaries with a polygon geom and the name geom. And you get the idea. So we do a lot of that, and that helps us a lot down the line. Um, we also mentioned the geometry type and the region covered. That's also something that I said in the example, and highlight the primary geometry if multiple exist. And the third one that you likely saw in the demo is basically you use the execution feedback. And mainly this is when we find an error. We basically capture the DB error and convert it into what we call a schema tip. So let's say there's an error like, hey, the column G on poly does not exist. Table uses geometry or something like that instead. So we pack that into a tip back so that we are able to reprompt the LLM very easily, and we find that whenever we get into this the second time around, it works like a charm. So those are three big ones that we use in the system prompt, and that's been our session on how to help Claude think spatially. Thank you so much.